Good morning, boys and girls. In this video, we're going to be going over the answers to the Monday Spiral Math for Monday, May 11th. We're going to go ahead and get started. I've got my answer and my work, and I'm going to go ahead and look at number one. Number one, we're going to be classifying the triangle based on its sides. And the key thing to remember here is that we're talking about sides, boys and girls. So what we're going to do is we're going to write an answer sentence. I'm going to go and just put here, it is a blank triangle. And since it looks like here, when I look at the sides, they are, well, each one of them is actually the same. It's 16 feet, it's 16 feet, and it's 16 feet. That means that all three sides are the same, and when they're all equal, they're all the same, they're all congruent. It is an equilateral. I kind of moved over to the side there because I kind of ran out of space on my line. It is an equilateral triangle. And try to spell it correctly. Equilateral triangle. And I'll put a period at the end of my sentence. All right, great. Now let's move on down to number two. We're going to write the number in expanded form. So we're going to take a look at our number right here. It's 0 and 488 thousandths. So I'm going to write it out as such. I'll write my answer sentence, the number in expanded form is, and I'll go ahead and write it on out. So I don't have any whole numbers, so I'll start first with my decimal, which is 4/10. So I'll put 4 multiplied by 1/10 in parentheses. You can either also use it as decimal 0.1 if you wanted to do that for 1/10. Then we're going to add 8 hundredths in parentheses, 8 times 1/100. Or again, the decimal, and I'll just put the decimal equivalent here, 0 and 1/10. And here is 0 and 1/100th. And then we'll go ahead and add our final part to it, which is 8 times 1,000 to get 1 or 8 thousandths. Or we could write here the decimal, 0 and 0.001 1,000ths. We'll go ahead and move on down to number 3. On number 3, we're being asked to divide. So what I'll do is I'll put my answer sentence as an expression, 16 and 4/10 divided by 4/10. What I'll do is I'll go ahead over to here and go sideways. My dividend is 16 and 4/10, so I'll place that inside the dividing box. And then my divisor is 4/10. I'll put that on the outside. I can't divide with a decimal. I need to turn it into a whole number by moving the decimal over until I get to a whole number. All I have to do is move the decimal over one place to get 4. So it becomes 4. Whatever I do with the decimal on my divisor, I must do with the dividend since I moved the decimal over 1 to the right on my divisor. I'm going to be doing the same thing with my dividend. Moving the decimal over one space to the right. So now my dividing becomes 4. I'll just rewrite it again down here. 4 divided by 100, or 164 divided by 4. So now I can go ahead and divide. Since the decimal's at the end here, I don't need to put it anywhere down here. So 4, I have to start with a 0, and since I'm not doing a decimal right here, I just put an X to know that I'm not going to be multiplying anything to get 4, or to get 1. I'm going to then look at 16. 4 times 4 is 16. And that has no remainder. I'll drop down the other 4 that's in the dividend right here. 4 times 1 is 4. I'll multiply that out and subtract, and I have no remainder now. So my quotient is going to be 41. 16 and 4/10 divided by 4/10 is equal to 41. Now we'll go ahead and move on down to our next number, our next problem.
Number 4, this time we're going to be focusing on classifying the triangle based on its angles. So the key here is that we are looking at the angles. We don't care about the sides here. We don't care whether it's an isosceles or scalene or equilateral triangle. We're looking to see if its angles classify as acute, obtuse, or right. There are no right angles on this thing, so I know it's not a right triangle. And when I look at each one of the angles, I notice that each one of them looks like, yeah, they are. They're less than 90 degrees. They're, each one is an acute angle. And because all of them are acute, meaning that they're smaller than 90 degrees, this makes it an acute triangle. It is an acute triangle. Now, it also is an isosceles triangle, but that's not actually what the question was asking us. It was asking us for the classified based on its angle. So if you said isosceles, it's technically incorrect because you weren't actually reading the directions. If you said it was an acute triangle, you're right on. Just make sure you check your spelling, acute, to make sure it's spelled correctly. I'm going to go on down to number 5. Jan's lunch bill is $5.74. She pays with a $10 bill. About how much change does she receive? And the key phrase here is the word about. About means that we're going to be doing some rounding to make it easy to do in our head. So we'll go ahead and I'll make my answer sentence and then I'll go ahead and do some rounding. So it says about how much change does she receive. I'm going to say she receives about, make sure you have that word about in there because we don't want to talk about how we're going to be rounding this. She receives about, and I'll put the dollar sign, blank dollars in change. Now that I know that it is going to be some rounding, I'm going to take a look and see what I need to round. $5.74, we should probably round that up to a nice whole dollar amount. So $5.74. When I look at the 5 as my nearest whole dollar amount, I'm going to then look at the tenths, and the tenths is 7. So that means that 5 or more raise a score. So I'm going to raise that 5 up to 6. So $5.74 is about $6. I don't need the decimals on the end of that. Now, over here on the other part of the word problem, it says she pays with a $10 bill. I really don't need to round that. It's already a nice whole number without any decimals, so it's pretty easy to do in my head when I subtract. So what I'll be doing is I'll take the $10 and subtract the $6, which is about $5.74 is about $6. So that's my rounded amount. So 10 minus 6 is $4. So she receives about $4. She receives about $4 in change. All right, let's go ahead and go on down now to number 6. On number 6, I'm going to zoom in, see if I can zoom in just a little bit here. Which of the following figures is an obtuse triangle, and how do you know? Well, an obtuse triangle is an angle or a triangle that has an angle, one angle in it, that is obtuse. Obtuse means more than 90 degrees, greater than 90 degrees. Let me go ahead and zoom in on some of these triangles a little more to see which one are definitely not more than 90 degrees, so I can at least eliminate those. So I'll take a look, and I'll take a look at, first of all, letter D. That kind of looks like each one of those angles there is less than 90 degrees. So triangle D is definitely not an acute or an obtuse triangle. So I'll go ahead and just cross that one out. That one's not going to be. And I'm going to look up at B. And again, it looks like each one of these is less than 90 degrees. Each one of these angles is less than 90 degrees, so I'm going to cross that one out too. That doesn't look like it's the right one either. I just added a random circle there. Letter C, let's see what triangle that looks like here. I'm going to look at each one of the angles. That definitely is not one. That definitely is not over 90 degrees. And this one, like it's just a little bit, it's either a right angle or it's just a little bit less than a right angle. So no, these are not obtuse angles, either one. That's going to leave me with letter A. So let's take a look at letter A close up one more time. And we'll see if that one has some obtuse angles. Now, when I look at it, this angle is not obtuse. It's not more than 90 degrees. This angle is not more than 90 degrees. But this angle at the very top, this angle right here at the very top of the triangle, if you turn it, and I can't really do that on my paper, but if you look at it, it is just slightly more than 90 degrees. This angle is an obtuse angle because it's slightly more than 90 degrees. That's how I know that this triangle, and I can say it's triangle A because it doesn't have a name, just triangle A. So I can say that triangle A is an obtuse triangle. And the part of the question also asks, if you remember here on the question, it asks you, how do you know? How do you know? So what I want to do is I want to say, because. And instead of just saying, well, because it has an obtuse angle, you want to say because one angle is more than 90 degrees. It's not wrong if you said one angle is obtuse, but it's even better to say, well, triangle A is an obtuse. I forgot to say triangle A is in here. Let me go ahead and add that in. I made a little bit of a copy error because I was saying triangle A, but I wasn't writing it. Triangle A is an obtuse triangle because one angle is more than 90 degrees is probably the best way to say because here, because you want to explain why it has an obtuse angle. All right, let's go ahead and we'll go on down to number 7 now. On number 7, we're going to be multiplying. We're going to multiply 3 24/100ths by 10. So I'll put my expression right here, 3 24/100ths multiplied by 10 equals. What I'm going to do is I don't really have to do any multiplication here except for some mental math. And I'm going to just go ahead and draw that over here. When I multiply by 10 or 100 or 1,000, anything with just a 1 and some zeros by it, I can use some mental math and just move the decimal over. I move the decimal over in my first number by the number of zeros in either 10, 100, or 1,000, or 10,000, or beyond. So in this case, I have 1 0 in 10. So that means that I'm going to move the decimal in 3 24/100ths. I'm multiplying, so I'm moving the decimal to the right. When I multiply, I move the decimal to the right, the same number of zeros that I have in 10, which is 1. So now I'm going to take and move the decimal 1 space to the right. And now 3 24/100ths multiplied by 10 is now 32 4/10. And that was just by moving the decimal over 1 space to the right. No need to actually multiply, just a little mental math. Let's move on down now to number 8. Just zoom in here. Let me zoom out a little bit so you can see it. Oh, this is the big long one, so let's make it that. All right, I'm going to put this one up here so it's a little bit easier for us to read. Janie skates at the local ice skating rink for 2.4 hours every day. If the skating rink is open 54 days a year, about how many hours does Janie skate each year? All right, so here's the key word again, the word about. Now, about means I'm going to be doing some rounding, so this is easy to do in my head. Now, there's 2 ways you could have done this, but before we do anything with rounding, I want to go ahead and add in an answer sentence. Since the question is about how many hours does Janie skate each year,
I'll say that Janie skates, and I'm going to make sure I include the word about blank hours each year. And I'll put a period at the end. Janie skates about blank hours each year. Make sure you have the word skates, hours, each year. Those are the critical words in this answer sentence. Now I'm going to go ahead and back and look at my word problem. And since it says about, I want to round these numbers so it's easy for me to do in my head. There's two ways you could do it. You could either take, and since it says Janie skates about 2.4 hours every day, I could round 2 4/10 to make it easy to 2. Since 4 last letter rest means I'm going to take this 2 and just leave it alone. Now, it says that the skating rink is open 54 days a year. So I could just add, it's either you could, if you could feel comfortable multiplying 2 times 54 and doing that in your head and getting 108, that's fine. If you want to also, you could have done this. You could have rounded 54 to about 50. And 50 times 2, which is the rounded amount, that I could do in my head too for 100. Either way is okay. I was going to round it this way for my answer. Janie skates about 100 hours each year. You could also say Janie skates about 108 hours each year. Either one is fine. All right, boys and girls, that's our spiral math for today, Monday, May 11th. If you have finished this and checked your work, make sure you fill out the survey so I know how you did on it. And if you have any questions, just email me. Thanks again, boys and girls. Bye-bye.